Dear students, good morning, good afternoon, and good evening. Based on the time zone at presently you are staying. First of all, I welcome all of you for our YouTube channel. You know very well, I am Selvamni Krishnamurthy, who is sitting in front of you. This is Machine Learning video lesson number 6. In this lesson, let us study how logistic regression works. Okay, how logistic regression works in detail. For that, we can take one small data set, not big data set, one small data set, how it works using Excel. Then we will go for how it logistic regression works in machine learning. As usual, I like to share my screen. I hope my screen is visible to all. So, lesson number 6, topic is understanding logistic regression. This is what topic. See, logistic regression is used for binary classification. Already for the past two lessons, we studied what do you mean by binary classification, where the output y can be either 0 or 1. That means if output are either 0 or 1 means that is binary classification. The logistic regression model predict y, that is output y, for given input x using probability function. That function is called sigmoid function. How linear regression works on the best fit of line. That means y equal to mx plus b. In same way, logistic regression works using this function y equal to 1 divided by 1 plus e to the power of minus z. So y equal to 1 divided by 1 plus e to the power of minus z, where z equal to w0 plus w1x. This W0, W1s are constant. W0 equal to minus 3. W1 equal to positive 1. For given value, first we need to find out Z. Then we need to find out Y. This is called logistic regression model sigmoid function. First, let us consider one small data frame. Then how logistic regression predict the output result for input hours using Excel. Okay, so to create logistic regression algorithm for the following data, we can consider hours as input, result as output. That means what? If any student studied less number of hours, he may fail. If any student studied more number of hours, he may pass. This is normal strategy. See the data set. One student studies only 1 hour per day, but he pass. One student studies 2 hours, he failed. One student studied 3 hours every day, still fails. So 4 hour pass, 6 hour pass, but even though one student studied 5 hours, failed. So this 1 hour studied pass gifted students. Okay, there may be possibilities. Some student will study only 1 hour per day, but still he will pass. Some students are low ability students, even though he studied 5 hours per day, he may fail. Okay, these are called anomalies. This 1150 called outlier. Normally, students study less number of lessons per day, he may fail. Students study more number of hours, he may pass. Okay, so how to remove these anomalies and how logistic regression correctly predict the result? That is what we are going to see. See, in Excel, I created 2 column hours and the result. After that, I find Z. Okay, then minus Z by using this formula. W0 should be considered as minus 3. W1 should be considered positive 1. A2 means 3. Sorry, A2 means 1, number 1, X. Here A3 means 2. So I created one formula to find Z and then ZX. Now ZX is ready. Now I try to find a predicted result. 1 divided by 1 plus e to the power of minus 1. Now minus 1 is available in D2. So I find predicted result. But predicted result in decimal places. the rounded predicted result, round of E2, comma 0. So 0, 0, 1, 1, 1, 1, 1. That means what? If any student studied for 1 hour per day, he may fail. If any student studied for 2 hours per day, still he may fail. If any student studied for 3 hours per day, he may pass 4 hours, 5 hours, 6 hours. This is what rounded predicted result we found using logistic regression formula. That is 1 divided by 1 plus e to the power of minus z. So minus z. Z means W0 plus W1 x. W0 should be considered as minus 3. W1 should be considered as 1. Okay, now let us plot the scatter plot for hour versus result, then hours versus rounded predicted result. This is the scatter plot using result versus hours. This is anomalies, this is anomalies. This is the scatter plot what we created using Excel, hours versus rounded predicted result. This comes down here. This comes up here. That means a student who studied for 5 hours pass. A student who studied for 1 hour fail. Okay. Now let me explain the same thing in front of you using Excel. After that, we can go for machine learning. So now my aim is I want to perform logistic regression using Excel. Let us consider the same data set. First hours, then result. 1 hour, 2 hour, 3 hour, 4 hour, 5 hour, 6 hour. Even though the student studied 1 hour, he passed. 0, 0, 1, 0, 1. This 1, 1 anomaly, 5, 0 anomaly. Okay. Now I need to find out Z. Z equal to W0 plus W1 of X. In this case, 0 I want to make it a subscript. Similarly, 1 I want to make it as a subscript. It is not necessary to make you understand. I do it. Now, okay. Now I need to find out Z. Okay. Equal to open bracket. Sorry. Equal to minus 3. W0 stand for minus 3 plus W1 stand for 1. Multiplied by X is available in A2. So I got minus 2. Okay. Just to drag it. I got Z for all X. Let me check. So all are correct, no problem. Now I need to find minus Z. I need to find minus Z. I can change this column as a text so that I can type minus X. Minus X. You know very well, equal to minus 1 multiplied by C2. Minus 2 become positive 2. Minus 1. This is what I got it. Now I have minus Z. Now I need to find predicted result. So predicted result is X equal to, we know the formula, 1 divided by 1 plus e to the power of minus Z. In this case, minus Z should go up. Superscript. I hope it is clear. Now already I have minus Z equal to 1 divided by 1 plus exponential of minus Z. Minus is available in D2. I hope it is clear. Let me check. So I got correct result. Minus 119 minus 268. So I need round off either 0 or 1. Okay. Now rounded predicted result. You know very well how to round off. Equal to round off E2, comma 0 decimal place. I don't want 0 decimal places. So 0.11 becomes 0. 0.2 becomes 0. 0.5 becomes 1. 0.7, 0.8, 0.1. So this is what my rounded predicted result 0, 0, 1, 1. The student who was studying less than 3 hours may file. A student who was studying 3 or more than 3 hours pass. So far, no problem. I think is it clear. Now let us proceed for scatter plot. First, both column I can select. That is hours and original result. Go to insert, scatter plot. This is, I got this plot. Okay. Let me make it small. Fine. Some anomaly is there. Our aim is this should come down, this go up. Okay. Now I select hours and then press Control. Select rounded predicted result. I need scatter plot for hours versus rounded predicted result. See it here. See it here. So those are studied less than 3 hours, 5. Those are studies 3 hours or more than 3 hours are pass. I hope it is clear. Our logistic regression is predict the result correctly. Okay, this is the what concept. Now let us explain the same logistic regression, how it works using machine learning. So far, no problem, I think. As usual, pandas as PD, matplotlib, I imported. I create one data frame from hours underscore result.csv file. I have one CSV file. It has hours and result. This is what our data frame. As usual, this 1150 are anomalies. I created one scatter plot for hours and result. So far, no problem. Here, I need logistic regression. I import logistic regression. I create one logistic regression model. I train the model using input and output. That is hours and result. By using hours as a input, result as a output. Okay. Now I like to predict the result for the hours. Already I have result here 100101. Instead of this result, I need one more result, that is predicted result. This predicted result is predicted by our logistic regression model. So, okay, it predicted 000111. That means what? Any student, those are studying more than 3 hours, he may pass. Any student, those are studying less than 3 hours, they may fail. This is what he predicted. Again, I created one scatter plot for hours and predicted result. This predicted result is predicted by our logistic regression model. See, it's predicted before. This is hours versus result, original data set. This is hours versus predicted result. In this case, our logistic regression predict the result for existing model. That is 1, 2, 3, 4, 5, 6, 1 is predict. What will happen if new hours, one student studied 1.5 hours, 2.5 hours, or 5.5 hours, or 8 hours, which is not given here. Now, our logistic regression is properly trained. We can go for predict new result equal to logistic regression model predict 1.5, 2.5, 5.5, 8 hours. That means if any student studied 1.5 hours per day, they may fail. If any student studied 2.5 hours per day, still he may fail. If any one student studied 5.5 or 8 hours per day, he may pass. I hope it is clear. That means our logistic regression model predict the result correctly. Now let me explain the same thing. I don't want this. Okay, first I will need one CSV file I like to upload. Already I created one CSV file. I hope you know very well how to create one CSV file. My CSV file is hours underscore result. I uploaded. Okay. Now let me go for one new notebook. Here, first import and as PD, then import plot lib dot py plot plt. So I need one data frame df equal to pd dot read underscore csv. Here my data frame is hours underscore result dot csv. So let me check. So my data frame contains two columns, hours and result. It's correct. So let me insert one more cell. I need to plot one scatter plot versus df dot hours, df dot result. Let me check. I got it. This is anomaly. This is anomaly. Okay, fine. Now my aim is I need to create one logistic regression algorithm. You know very well how to create logistic regression algorithm. sklan dot linear underscore model of logistic. Okay. Now I need to create one object under logistic regression class. Logistic. This model needs to be trained. Here I get to give input as well as output. df of first hours. This is input, comma. Then df of result. So let me check. I created one logistic regression model. I trained the model with I made mistake here. It should be O, small o. Linear. I created model. I trained linear logistic regression model is properly trained with hours and the results. Now my aim is I need to predict the result using logistic regression for these hours. Okay, let me insert one more thing. Predicted result. Predicted result. Equal to lr underscore model dot predict. Here I need to give only input, no need to worry about output. Okay. Now predicted result. See, it's clearly displayed 0, 0, 0, 1, 1, 1. That means the student studied less than 6 hours, fail. The student studied more than 3 hours, pass. Now I need to plot one scatter chart for hours and predicted result. Now plt dot scatter df dot hours now predicted. See it here is correctly proper. Okay, now you understand how logistic regression predict the result or output using sigmoid function. Okay, still we have one more thing. These are the hours. What will happen if any one student studied 2.5 hours or 3.5 hours or 8 hours? Our model should predict correct value. So I want to check. Now here, new result. New result. New result equal to LR underscore model dot predict. Now new values are 2.5 or 1.5, comma 2.5, comma 4.5, comma 8 hours. That means I want to predict either what about the result for student, those are studying only 1.5 hours per day, 2.5 hours per day, 4.5 hours per day, 8 hours per day. Let me check. See, any student studied 1.5 hours or 2.5 hours, he may fail. If any student studies 4.5 or 8 hours, he may pass. So our logistic regression model is working or predicting result correctly. Now you understand how logistic regression works, how logistic regression predict the result using sigmoid value function with input. I hope all of you enjoyed this lesson. Today, let me stop here itself. In next lesson, let us study something extra. Until then, have a nice good day. Bye bye. See you.